Hello everyone, I'm Miyanshu. Today I will present a comprehensive analytics of ABC bank credit card approval dataset. Strictly follow the Module 2 homework requirements. I will walk you through my code from start to finish in demonstrating how data preprocessing and feature engineering directly impact our ability to solve a critical business problem. So as the material says, the business problem, ABC needs to automate credit cards approvals. The risk is twofold. The first is the financial risk approving bad customer leads to default. The other one is upon alternative risk rejecting good customers loses revenue. So our goal is to build a predictive model that balance accuracy with unpredictability. So there's a checklist, and after install so many libraries, we can start our project. The first is our data. Um, Data preparation is very important. So we need to learn about how data we need to use, and we process the loading, and we check our data information, and there are so many columns, so many rows. Okay, the first is our exploratory data analytics. We need to check out the first. This is the first that we need to look at this cell, and we need to run the code instant sum, and we check that output was zero, which means the data appear perfectly. We also need to learn about how many types of variabilities. This is the reason why we want to check our data set is good enough for us to run the machine learning model. Okay, let's get started. After cleaning, here use the auto viz for exploring data analytics, and you can see this code draws attention to the DQ issues here, and there are so many columns in summary data, and it shows three ways like the schooners. In fact, all the total income as high skewered. It also show me outliers because you can see there it automatically mentioned there are 31 outliers for this data set, 45, 83. So this models directly give us some possible issuance here. And we need to pay attention to the target imbalance, and this graph show us the ratio of approved versus rejected application. So these insights detect my next step. We need to apply imputation to fill the missing values we create, even though we didn't have the missing value. And we also need the standardized scaler to handle the skewness and scale this disparity between the features like the income and age. And from this model, we also show so many diagrams for us to learn about our data set, and we can see so many charts between different features, different variables, and it gives us a clear knowledge about our information. So the next, so the next is the important ways is the pre-processing, and which means we need to do our feature engineering. So the first feature engineering we need to mention is the PCA, the Principal Components Analysis. Moving sequence to our first advanced feature engineering technique is this way. We also call it the PCA. The logic is the financial data set often contains correlative features. So you need to initialize the PCA with component equal to 5. And our goal is to reduce the dimensionality of our data. So we can see on the chart, the result is projecting our data into 5 principal components. We can capture the majority of variance while reducing noise. This is a particularly useful if we want to speed up training or visualize high dimension data. Another way is original feature importance and classifier development. Before replying on the PCA, I want to understand the original features. We need to train the baseline and then forward to extract the feature importance. As this shows so many feature importance here, and we need to have a key finding. which shows the plus clearly shows the different ways to and we need to check the age, like the age, the years employed, the account length are the most dominant predictors. This aligns with financial logic, and so many past behavior is the best predictor of future behavior. So the classifier development, I then train my baseline models like the logistic regression and random forest. We also show many indicators to show our model is good enough, and by this way we can check how strong for this model's performance. So the observation is random forest outperform the logistic regression because you can see the predictors uh, for different values. That we need a higher accuracy with the label encoding. So this suggests that the relationships our data are non-linear, which a simple linear line cannot capture effectively for our features. So for the comparison with and result using key means cluster, it's an experiment satisfied to learning objective of engineering new features using clustering. We apply the k-means clustering to groups customer into two distinct clusters based on their similarities. I then add the cluster labels as new feature to database, and then compare the performance of models trained with these two new feature versus resulted. So the conclusion is the results show adding cluster provide a comparable performance to baseline because we can see it shows a higher accuracy for here. Um, and since our supervisor features like the Pioneer default are already very strong predictors, the unsupervised cluster didn't add significant new single. However, this verifies that our baseline model is already robust. Yes. So there's another important model like called the H20 auto machine learning. Finally, it's a most powerful tool in this notebook. Instead of manually turning high parameters, this machine learning automatically trains and validates a wide range of models, including like the GBN5, GBN1, so many GBN and like the XRT, XGBoost, DF, DRF, deep learning one, so many machine learning models here. So looking at the leaderboard, the stacking ensemble models ranking first with the highest AUC. It combines the strengths of multiple algorithms effectively, canceling their individual weakness, which can capture the complexity patterns that single models misses. So to conclude, I will not interpret this result to answer the assignment discussion question. So what which is the best perform models. And really, I would like to say the H20 stack ensemble is the statistically the best performing model. The dataset contains a complex nonlinear interaction between count depth and history ensembles naturally handle so there's complexity better than single linear models. Um, but um, but we want to interpretability models. So in this banking sector, we are in legal require explain rejection. So it is we need to give a reasonable for those customer who was rejected by us. For this H20 ensemble, it's a black box. So the random forest offers a perfect balance. It has a high accuracy, very close to H20, but provides a clear feature importance to explain the decision to stakeholders. That's why I want to use this for the ABC Bank. And the last one is how could it further improve the performance? I would say it adjusts the decision threshold from 0.5 to higher value to prioritize the precision. I want to avoid in bad depths like the false position. It's more important for the blank than approving everywhere's possible customers. As seen in the auto-read DQ reports, I will apply log transformations to the scored income columns to help model learn better. Thank you for watching.